Hey guys, so today I wanted to showcase another project of mine, which is this esp32 smartwatch. It mounts a LCD screen through the connectors here and mounts onto the screws perfectly so that it sits on your wrist like a watch. Um, I built this myself. I designed the four-layer board and I assembled it myself. So if you can see how bad some of the joints are. You see some solder on there. Yeah, it's not that good. This isn't my first board. Um, this was the first board. It looks terrible. It was, difficult to assemble, but it was version 1. As you can see, Kairos 1. I attempted with this one as well, but I just couldn't get the microcontroller on there since the pads were underneath the microcontroller, as you can see. It just didn't connect very well to the computer, and so I changed it to a different package which had the connections on the outside, on the edge castellated. I don't know what it's called exactly, but yeah. And so this was the original board without anything, and this is the newer board. I configured for a bigger sized microcontroller, just changed the orientation of the boots and the reset button. And yeah, there are a lot of small components here, which made it very difficult to actually solder onto it. And as you can see, I'm missing a few components here, like this one, which is supposed to be a, let me see, let me make sure. It's a real-time clock, works without internet. Then I have a analog to digital converter for the battery, for checking battery voltage or battery health, I guess. And this really small one, I don't think you can see it very well. It's very small, right there, very small block. That is the magnetometer or the compass, which would work great if I can actually solder that on. But the pads are underneath, and the component is just super small, so I'll have to try that later. Um, so yeah, I want to show you everything. So let's check it out. So here we have the schematic and the PCB layout for the board. Um, let's start chronologically from where it would begin. Here we have the USB-C receptacle, which is where we connect to the computer for power and data. Here we have the data lines. These pins are connected to each other because no matter the orientation of the USB-C entry, it will work. Whether you have it right side up or down side up, it will still work either ways. We have here the V-bus line, which is what's mainly powering our board for now, while we don't have a battery pack, and the filtering capacitor. We also have a current protection right here, which protects against reverse current and stuff. I believe so. Something like that. Anyways, we move on for the USB from the USB 5 volts to here, which is the charger circuit, which takes in 5 volts and outputs to the LiPo VCC 5 volts still. Once all of these circuitry that I have here is from the data sheets, which are like the recommended layouts for these chips. This specifically here is my LED indicator telling me that the unit is charging, or I guess the battery pack is charging itself. So we have here from 3.3 volts, which we'll get to in a second, 10k ohm resistor for the LED so it doesn't burn out. So from there we have the, what you call it, where is it? We have the linear regulator, which takes in the LiPo VCC, right? It's permanently enabled, so no buttons or anything is connected to it. Filtering capacitors, and it outputs a stable 3.3 volts because of the capacitor and everything around it. That's one. The 3.3 volts basically goes to every other sensor and chip that I have on here, like the magnetometer here, which is like the compass of the build. We also have the what you call it here, the real-time clock, which does not need internet to function. It works perfectly fine Wi-Fi-less. It's not a word, but yeah, whatever. The analog to digital converter, which is supposed to give me a good, perfect, like perfect battery percentage on the battery pack. So, and I also have my 3.3 volt indicator LED, which I did not label because I forgot about Edo. And then we have here the microcontroller unit, which is the main big boss of this build. And all of this circuitry is very, very important. I would like to stress that. This is one of my first microcontroller builds, my first time making something like this, so I did not fully understand. And as I assembled this myself, I thought it would work completely fine without the capacitors and stuff that were integrated. I just wanted to test it first. But I came into the issue where my computer would recognize that something is connected to the MCU, but it would not stay connected. It would just beep, connection, beep, disconnection, and it would loop like that forever until I added the filtering capacitors and all the circuitry that's around here, which is very important. Can't stress that enough. Anyways, here we have our layout, our physical layout. I chose a 4-layer board simply because it was getting very crowded to try and it was getting very crowded and I couldn't just put everything out there. I couldn't route everything. So I made a ground plane right here, and I made a 3.3 volt plane, and I used the top layer and the bottom layer as routing planes, which made everything pretty well. As you can see here, this is mainly where my LCD screen is being placed. It is using an SPI communication protocol. So I tried my best to route not perfectly, but with 90-degree angles, as I know it messes with the signal integrity. Although I don't really know if that's hugely affecting my build here. So we're back now, and we're gonna put it together and see how it looks complete. All you have to do is screw this on, just like this. Just enough to sit nicely. And just like this, it's pretty nice. Only the top part of the antenna shows up, which is what I intended for. And now we get to connect it. It powers up. Press the button. And look. Right there. And as you can see, the main issue is the LCD screen. It just doesn't look really good. I believe it's my soldering, perhaps, or the connectors aren't good enough. I'm not really. Maybe the connections are too close to each other, but it just overall does not look too pretty. If anyone has any advice or something, that would be greatly appreciated. Thank you for watching. And boom, this is with the wrist strapped hot glued on. It's not that good, but it serves its purpose for now. I like how cool it looks. Reset it. Let it connect to the internet. Right there, connected. And then back to the time. Right now we're still working the software. Doesn't have too many uses yet besides time and temperature. Right there. Yeah. Yeah, like I said, not many uses just yet, but it's gonna look really cool. Thank you for watching.